everyone, and welcome back to our functions lessons. And in this lesson we will learn how to draw the exponential function. Now here I included the remember because you have to remember that Q is the asymptote. A tells us if the exponential function is above or below the asymptote, and here if A is greater than 0, in other words A is positive, then the function is above the asymptote. If A is negative, in other words less than 0, then the function is below the asymptote. What does B tell you? B is the value that is to the power of x, in other words that base number that is to the power of x. This tells us the shape of the exponential function from left to right. Okay, so if B is greater than 1, the graph moves away from the asymptote as we read from left to right. And if B is greater than 0 and less than 1, the graph moves towards the asymptote as we read from left to right. So now let's go and see how we will draw the next exponential function. Now before we start, I want to remind you that the exponential function is of the form y equals a times b to the power of x plus q. Okay, so now draw in the asymptote. Now what is my plus q in this example here? And I know this is an exponential function because x is an exponent, right? That's how I know. So this will be plus 0. So basically my asymptote is on the x-axis. So let me draw that in. Very important, draw in your asymptote first. So there it is. I keep drawing it. There we go. And there it is. Then I can also name it because I know that this will be y equals 0 because any horizontal linear line is y equals to the place where it goes through the y-axis, which is 0, right? Okay, now here we go. So now I first look at the 3. The 3 is my a. What does a tell me? If a is greater than 0, in other words, if a is a positive, my exponential function will be above the asymptote. So it will be drawn here and not at the bottom. Okay, so great. Now I already know that. Then I go and look at b. Now what does b tell me? B tells me the shape of my exponential function. Now if b is greater than 1, which it is, the graph moves away from the asymptote. So I already know the basic shape. It will be above the asymptote, and from left to right it will move away from the asymptote like this. Okay, so let's go again from left to right. It will go like this. So it's somewhere along the line it goes through my y-intercept. So I need to go and figure out where is the y-intercept. So find the y-intercept by making x equal to 0. So that's easy, you already know that, because any y-intercept, my x will be equal to 0. So my y-intercept, this will be y equals 3 times 2 to the power of 0 because x is now a 0, right? And then we know that this will equal to y equals 3 times 1 because any base to the power of 0 is 1. So y will be equal to 3. Okay, got it? 3 times 1 is 3. So y will be 3, that is right there. And I can put in my dot there just to plot that point. Okay, so I know the graph will be above the asymptote. It will move away from the asymptote through that point and upwards. Now to draw it correctly, I must also find the x-intercept, but I know it will not cross the x-axis. Why not? Because my asymptote is on my x-axis. Okay, so I don't need to calculate my x-intercept. If I needed to, in other examples, we just make the y 0 and then solve for x. Okay, but now we don't need to, so we need to find one more point by choosing your own x value and solving for y. Okay, so let's quickly do that. It can be any one of these values of x because it will be, the shape will go like this, right? So let me just quickly go and draw in a little table because we want to draw it accurately, and this helps me just to go through the correct points. So there's my table. So I'm just going to choose two easy values for x, which is minus 1 and 1, and let's do that. If x is minus 1, and now we have to go and see, and this is a bit more complicated to work this out, so y will equal to 3 times 2 to the power of negative 1, and that will equal to 3 times a half, And we know that this is a half because 2 to the power of 1, we move it to the bottom of the line, it's 1 over 2, and that means it's 3 over 2, which is 1.5, right? So if x is minus 1, y will be 1.5. So let's go and plot that point. X is minus 1, and then y will be 1.5, which is between 1 and 2, so it is right over there. And then the next one we can choose is, for example, a 1. Let's make x into a 1. So if I quickly do that sum, y equals 3 times 2 to the power of 1. So that means 3 times 2, y equals 6. So that means that y will be 6 if x is 1. So where do we find that point? 1 and 6, that's way up there. And this kind of gives us the idea the way the line is going to go. So if I draw it in, it has to go through that point, it goes through my y-intercept, it goes through that point, and it keeps going down. But remember, it's never gonna cross my asymptote. And there we go. And we can put in those coordinate points if we want to. And this will just be a minus 1 and 1.5, right? Okay, there we go. And then we are done. So that's quite easy to draw if we already know the shape. Usually they don't ask us to put in all these points. Sometimes they ask us to put in one more point, so you choose your own x value and then you just calculate your y. Other times they just want to know where the asymptote is and where your y-intercept is. Now let's go and look at another example. Now in this example, we want to draw the following exponential function. So again, draw in the asymptote. What is my asymptote? It's minus 1, so it will be here. So let's go and draw that in. So I draw in my asymptote. It goes through minus 1. There we go. Keep drawing it, and there it is. So y equals minus 1. Because again, horizontal line that goes through my y-axis is just y, and it's equal to the place where it goes through my y-axis. And there it is. So find the y-intercept. Now before I do that, let's just figure out something about this exponential function. Well, what is my a? My a is a 1, and it's positive. So in other words, it will be above the asymptote. Okay. Then b is a value greater than 1, so it will move away from my asymptote from left to right. So now we know at least that the shape is like this, okay? So it will go through the x-axis and it will go through the y-axis. So I need to find my y-intercept and my x-intercept. So let's do that. So my y-intercept, how do we find that? We make x 0. So that means y equals 3 to the power of 0 minus 1. So that means it's y equals 1 minus 1. And look very closely, that means my y equals 0. So this will go through this point 0 right there. And now I don't even have to work out my x-intercept, but let's do that for curiosity. So to find the x-intercept, we will say the following. 0 equals 3 to the power of x minus 1. That means take the minus 1 to the other side. It's 1 equals 3 to the power of x. And do you remember exponential equations? We want the bases to be the same. How do I make a 1 into a 3? We write 3 to the power of 0 because 3 to the power of 0 is a 1. And that's equal to 3 to the power of x. Now the bases are the same and the exponents will then be the same. So 0 equals x. So my x-intercept is also at 0, and that's what I knew earlier on, because if it goes through 0 on the y-axis, it goes through the x-axis also at 0. Okay, so but I just quickly showed you how to calculate it. Now, we need to find one or two other points, so let's quickly do that. We draw in our table x and y, and we find two other points for x. And let's quickly see. I am going to choose here, let's make it x is a minus 1. So if x is a minus 1, our equation will look like this. It will be y equals 3 to the power of minus 1 minus 1. So that will be y equals a third minus 1. And then we will get y equals minus 2 thirds. So this will be minus 2/3. Now to go and plot that point. If x is -1, y will be -2/3, which is between 0 and -1, so it will be somewhere there, right? Okay, let's just make it there. There we go. Now we have to go and choose another value for x. Let's make it x to the power of 1. So then to easy calculate it, it's y equals 3 to the power of 1 minus 1. Where did this come from? Well, it's the initial equation, right? So it's 3 to the power of x minus 1. I don't have to include that a because 1 times anything is that anything anyway. So 3 to the power of 1 minus 1, that gives us y equals 2. Okay, so if x is a 1, my y will be 2. Let's go plot that point. If x is 1, y will be 2. That is up there. There we go. There's my other point. And now I can easily go and draw in my graph. It has to go through all these points. And then it goes up steeply like this. And it continues to go up. And it doesn't cross my asymptote, and there we go. And you can put in the coordinate points there if you want to, if you don't have grid paper. And it's so important when you draw this, make sure that your spaces are equal, okay, if you don't get this grid paper. And there we go. So we drew in the asymptote. Then we just looked at the equation to see what kind of a shape it will be and where it will be. And then we found the y-intercept and the x-intercept, and then find one more point by choosing your own x values. I just found 2 more points because it helps me draw my graph more accurately. Now let's go and look at one final example. Now here is one more example, so let's have a look at drawing this exponential function. Again, this is an exponential function because x is an exponent. So draw in the asymptote. What is my asymptote? -3. So it is over here. So let's quickly draw in the asymptote. That's so important. That's the first step. And now I know there is the asymptote. So my exponential function can never cross this line. Okay, brilliant. Now, what about the next step? First of all, before I start running with those steps, I just go and make sure that I know where this graph is going to go. Now, A is a +1, so it's going to be above the asymptote. B is a value that is greater than 0 but smaller than 1. It's a fraction. So basically, this means that this function is going to go towards the asymptote. Okay, as we read from left to right. That is what the B means when it is a fraction that is greater than 0 but smaller than 1. So I know the shape will look like this. Okay, so it will go through my x-axis and it will go through my y-axis. And so my job is now to find my y-intercept and my x-intercept. So here we go. So let's find the y-intercept first. Now to do that, we say y equals 1/3 in brackets to the power of 0 because the y-intercept on the y-axis, my x will be 0 and -3. So then it's easy to calculate this one. Y equals 1/3 to the power of 0 is equal to 1 minus 3. So y is equal to -2. Okay, so now I know my y-intercept will be at -2. Let's go plot that point in blue. There it is. Okay, great. Now, let's find the x-intercept. Now, to find my x-intercept, what do? We have to make y equal to 0. So 0 equals 1/3 in brackets to the power of x minus 3. Okay, great. Now, first of all, move the constant. So -3 goes to that side. It becomes a +3 equals. And then I want the bases to be the same. So I can rewrite the third as 3 to the power of -1 in brackets to the power of x. Right? You remember this from our exponential equations. Now, what do we do next? We simply write 3 equals 3 to the power of -1 times x, which is a -x. Okay, brilliant. My bases are the same, so that means this exponent there, which is a 1, is the same as that exponent. So then it means that 1 equals -x. And then we know that x is equal to -1, because then the coefficient here is a -1, so 1 divided by -1 is a -1, so my x-intercept is at -1. Okay, and there it is, there we go. So now I've got my x-intercept, my y-intercept. It's actually enough, but let's draw this accurately. So what I'm going to do now is I'm going to choose two values for x, and then I find their y value so I can draw it properly. So let's do that. So there is my little box, and then let's choose two x values. Now let's make the one x value, how about we make it into -2. Okay, so x is a -2, and then we just substitute that -2 into x's place. Now that takes a bit of calculation. So y equals, then we say a third to the power of -2 minus 3. Okay, we substitute that -2 into the x's place in our initial equation. And now from here I can quickly say, and you can calculate this on your calculator, you don't have to waste time doing this manually. So we know that we have a third, and just keep the third in brackets on your calculator. That's important. And then we raise it to the power of -2. Okay. And then if we are finished, you press equal, and you will see that your answer will be a 9. So this will just be y equals 9 minus 3, so y equals 6. So if x is a -2, my y will be a 6. Okay, so let's plot that point. -2 and 6, that's way up here, and there it is. Okay, brilliant. And let's choose one more value. Well, it's not necessary because I can already kind of see the shape here, so let's just draw this one in. If you wanted to choose another value, maybe choose a 1 there. Okay, so let's do that for practice. That is a 1, so let's just go put that into a value, and I'll do that calculation up here because I'm running out of space here at the bottom. So y equals, then we have a third in brackets to the power of 1 minus 3. So y equals a third minus 3. And then if we take a third and we minus 3, what do we get? We will get minus 2,66667. So that is minus 2 2/3, right? So basically then we will get minus 2 2/3 roughly, and that means here my y is equal to minus 2 2/3. So what I need to do is I need to quickly go and find where that point is. So if x is a 1, y is minus 2 2/3, which is down here somewhere, right? So that's the other point there. There we go. And now we can easily see the shape. And isn't it the shape that I pointed out earlier on when we just looked at the example? So let's go and draw this in all the way down through the x-intercept, through the y-intercept, through that point. And then it can never touch this asymptote, right? There we go, and it continues up in that direction, and there we have our exponential function. And now you can see how it works. So please remember, always draw in your asymptote. Look at your a value to see if it's above or below the asymptote. Look at your b value to look at the shape of your exponential function, and then calculate your x-intercept and your y-intercept. Choose any other value just to make sure about the shape, draw it in accurately, and then you're done. Brilliant. So hope to see you in the next lesson, where we will look at determining the equation for an exponential function. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.